The first thing that we are going to do to start building out our consensus algorithm is we are going to create a new method called chainIsValid. And basically all it will do is validate if a chain is legitimate or not. So let's create this new method now. So down here, we will say blockchain.prototype.chainIsValid equals a function. And this method will take in a blockchain as an argument, and it will return to us whether this blockchain is valid or not. Simple as that. We are going to use this chainIsValid method to validate the other chains inside of our network when we are comparing them to the chain that is hosted on our current node. So in order to validate that this blockchain is legitimate, how are we going to do that? Well, quite simply, we are just going to iterate through every block inside of this blockchain and make sure that all of the hashes line up correctly. So you might recall that on every block there is a previous block hash property and there is a hash property. This hash being the hash of the current block that it is on. What we want to do is we want to iterate through every block inside of our blockchain and make sure that the previous block hash property of a given block is exactly the same as the hash property on the previous block. Simple as that. So let's build this out now. So in order to iterate through every block inside of our blockchain, we are going to use a for loop. So we will say for variable I equals 1 while I is less than blockchain.length. We want to increment I by 1 on every iteration. So I plus plus. Cool. So inside of this for loop, we want to compare the current block to the previous block. So let's identify what these blocks are now. So we will say const current block equals our blockchain at position I. And we will say const previous block equals our blockchain at position I minus 1. Cool. So as we iterate through our entire chain, on every iteration, the current block will be the value of I, and the previous block will be the value of I minus 1. Now all we want to do is we want to compare the previous block hash property on our current block with the hash property on our previous block. So let's do that now. In order to do this, we will say if current block at the property previous block hash does not equal our previous block at the hash property, then basically we know that the chain is not valid because our hashes are not lining up correctly. The previous block hash on our current block should be equal to the hash of our previous block, right? That makes sense. So if they are not equal to each other, then we know that the chain is not valid. So how are we going to signify that this chain is not valid? And let's just keep it simple by using a flag. So at the top of our method, we will say let valid chain, and we'll set it equal to true initially. So now we have this variable called valid chain here, and initially it's set equal to true. Now, as we go through our blockchain and test it, if we see any problems, like if the hashes don't align properly, we just want to set this valid chain variable equal to false to signify that the chain is not valid. So back to our if statement here. If the previous block hash on our current block does not equal the hash of our previous block, we simply want to say valid chain equals false. Cool. Easy as that. So at this point, we are iterating through every single block inside of our blockchain and comparing the previous block hash to the hash in the previous block. If they are not the same, then we simply indicate that the chain is not valid. And at the end of this method, we can simply return valid chain, and we will get returned to us true if the chain is valid, and false if the chain is not valid. Cool. Now, we're actually not done yet. One more thing that we want to do is we want to validate that every single block inside of our chain has the correct data. So how can we validate that every block inside of the chain has the correct data? Well, we can simply rehash the current block by using our hash block method, and if the generated hash starts with 4 zeros, then we know that all of the data is valid. But if it does not start with 4 zeros, then we know the data inside of our block is definitely not valid. So basically, all we want to do as we are iterating through every block in our chain is that we want to rehash every block and make sure that each hash starts with 4 zeros. So let's do that now. So down here, we will say const block hash equals this dot hash block, and this method takes in a couple of parameters. This method is going to take in the previous block hash, the current block data, and a nonce. So let's pass this data in now. So we will pass in the previous block hash by passing in the previous block at the hash property. Easy as that. Next, we have to pass in the current block data, which you might remember simply consists of the transactions in the current block and the index of the current block. And we used that previously in our mine endpoint. We use current block data, and we simply use transactions of the current block and the index of the current block to comprise our current block data. So we're going to use the same data again. So back in our blockchain file, for the current block data, we will pass in an object that has a transactions property, which is equal to current block at the transactions property, and it will have an index property, which is equal to the current block at the index property. Cool, easy as that. And finally, the last parameter that we have to pass in is a nonce. So in order to pass in the nonce, we will pass in current block at the nonce property. Easy as that. So now we should have the hash of our current block stored in this block hash variable. Now we just want to validate that it starts with 4 zeros. So down here we will say if block hash dot substring from 0 to 4 does not equal 4 zeros, then we want to set valid chain equal to false. Cool. So now basically we're iterating through our entire blockchain and we're simply checking two things. One check that we are doing is we are making sure that all of the hashes align properly. If they do not align properly, we indicate that the chain is not valid. The other check that we are doing is we are hashing every block and we are making sure that the block hash starts with 4 zeros. If it does not start with 4 zeros, then we indicate that the chain is not valid. Easy as that. Now, our method is just about done here, but one thing you might have noticed is that we are never checking our Genesis block for anything. During our for loop, we are starting at position 1 and totally skipping position 0, which is our Genesis block. Now, our Genesis block is kind of a special case because we made it ourselves without doing a proof of work. So in order to check our Genesis block, we just want to make sure that it has the properties that we initially put onto it. So in order to check our Genesis block, we will come down here outside of our for loop, and we will simply say const Genesis block equals our blockchain at position 0. Now we just want to check and make sure that all of the properties on our Genesis block are correct. So if we come up here where we create our Genesis block, we can see that we give our Genesis block a nonce of 100, we give it a previous block hash of 0, and a hash of the string 0 as well. So let's just check these properties to make sure that they're correct. So down here in our method, we will simply say const correct nonce equals Genesis block at the nonce position equals the value 100. Next we will say const correct previous block hash equals Genesis block at position previous block hash equals the string 0. Next we will say const correct hash equals Genesis block at position hash equals the string 0. And finally, we know that our Genesis block should have no transactions in it whatsoever. So let's just check to make sure that's true. So we will say const correct transactions equals Genesis block at the position transactions dot length equals 0, because we should have no transactions inside of our Genesis block. Cool. So if we do have a legitimate Genesis block, then all of these variables should be the value true. If any of these variables are not the value true, we simply want to change our valid chain variable to false, so that we know the blockchain is not valid. So let's do that now. So down here we will say if we do not have the correct nonce, or if we do not have the correct previous block hash, or if we do not have the correct hash, or if we do not have the correct transactions, then we simply want to set valid chain equal to false. Cool. Easy as that. And that completes our chain is valid method. So one more time from top to bottom, we are simply iterating through every single block inside of the blockchain that's passed in. And we are comparing the hashes on every single block to make sure that they are correct. If they are not correct, we indicate that the chain is not valid. We are also checking to make sure that every block has the correct data by rehashing every single block and making sure that our newly generated hash starts with 4 zeros. If it does not start with 4 zeros, we know that the data has been changed because our hash is now different, so we indicate that the chain is not valid. And then finally, we simply check to make sure that our Genesis block has all of the correct data. If it does not have the correct data in it, we simply indicate that the chain is not valid. And with this variable, we are simply returning true if the chain is valid and false if the chain is not valid. It's pretty cool. Okay, so that's it for our chain is valid method. In the next video, we will be testing this method to make sure that it works correctly. I'll see you there.